Welcome to Unite Now, where we bring unity to you, wherever you are.
Thank you for taking a moment to let us know where you are located. Really awesome to see folks all over the world, literally all over the world. So I hope wherever you are that you are doing well and staying healthy. Today we are going to be talking about HDRP, and we are going to be taking it a step further. So this session is building off the previous session, which was ran 2 weeks ago. So in today's session, we are going to dive right in to the high definition render pipeline and discuss creating the highest fidelity scenes possible. Really focusing on the lighting workflow in HDRP. So if you missed the last session or want a primer on HDRP, really encourage that you check that out. Go ahead and drop over to the Unity Learn page and you'll be able to watch a recording of that session there. But with that said, we will go ahead and continue on. This voice that is speaking to you through the computer, that is me. I'm Andy. I'm in the top left corner here, but I'm also joined by a few other instructors that are going to be helping answer all of your questions, and they are also responsible for helping put this thing on. So we have James, Ethan, Dave, Nicholas, Brian, and Mayor as well. So with that said, the outline for today, we're going to spend a few minutes here, getting up to speed with the session. Make sure you have the assets downloaded, make sure you have the project set up. Then we're going to dive right in. We're going to spend most of today's session working through a few challenges, setting up our lighting in the scene. Then we'll have a quick wrap up at the end. And as always, we encourage you to ask questions the entire time. We're all here to help answer those questions, so I really encourage you to use that QA tab. We'll talk about here in a second. The other thing I want to draw your attention to here is these icons on the right. So we have this stop sign, which is what I'm going to be demoing. So I'm going to encourage when the stop sign comes up that you just watch me demo. There'll be an opportunity for you to follow along and do it on your machine when you see this green thumbs up. And then there'll be an opportunity to explore as well. And I will call these out as we move through today's session. If you are new here, we have the recommended Zoom layout here. We find that this works well, especially if you're on a single monitor. Do want to call out that if you have a question, I see a lot of folks dropping questions in the chat. The best place to drop a question is in the Q&A panel. And so you can see that in the Zoom meeting bar there. So again, drop any questions in the Q&A, and then any comments, things like that, we can drop in the chat. The reason for that is that it's just easier for us to track the questions and make sure we answer all of them. So really encourage you to use that Q&A tab for any questions. We may have a poll or two, but I will let you know if those are coming out, and you can keep an eye out for those. A couple quick notes. We are going to be recording this session, so if you miss something or want to reference it later, feel free to find the recording on the Unity Learn site. The other nice thing about this is that previous sessions have been recorded. So if you missed the primer on HDRP, you can check that session out, as well as a plethora of other Learn live sessions. So really encourage you to use that as a resource for your learning. And then again, as a reminder, general thoughts, comments, drop those in the chat. Everything else, as far as questions go, should be in the Q&A. Today's goals, again, are going to be maximizing the fidelity in the scene. We are going to be using the same project that we used 2 weeks ago in the Up to Speed with HDRP session. But in today's session, we're going to focus on the scene lighting. So that includes baking the scene lighting. We're going to be talking about probes, both light probes and reflection probes. And then at the end of a little bonus here, we'll be talking about the Decal Projector and how to set that up in your scene and what you can do with it. So right off the bat here, we are going to want to make sure that for those of you following along at home, you have the project set up on your own machine. So we're going to take a few minutes here to make sure that you are all able to follow along. So the first thing that you're going to want to do is go ahead and go to the following bit.ly link. We'll drop this in the chat as well. I think there's actually a newer link, but we will drop this in the chat. You'll want to follow that and then download the project materials. So that is step one. So go ahead and just follow the link in the chat there. James posted that. Thank you, James. Go ahead and download the HDRP project files. When you have those files downloaded, just go ahead and drop a note in the chat and let us know that you have those downloaded. And if you have any questions, feel free to use the Q&A tab. The next step is going to be creating a Unity project. So this is going to be, similar to previous sessions. We are going to be using Unity 2019.3, and yes, you should use that version. We can't guarantee that it's going to work with other versions. So Unity 2019.3, the subversion is less important, but make sure that you are using Unity 2019.3. Go ahead and create a new project and make sure that you use the HDRP template. Again, we're not going to be setting the project up for HDRP today. We're going to be starting with a project that's already set up and then building on the lighting and increasing the fidelity of the project. So again, make sure that you select the HDRP template when you create that project. Great. We will continue on to the third step here. So once you have that project open, again, making sure that it is an HDRP project, go ahead and import the asset package that you downloaded. And if it's taking a second to import, no worries. Just want to make sure that you have the opportunity to get that set up so that you can follow along when we get to the challenges. So the first thing that I want to do here, I did receive some feedback that the project had some mixed results when importing into your Unity editors. So I do want to make sure that everyone is starting from the same place. So I'm going to just quickly do a demo, just showing you what it should look like at this point, and then make sure that we're all starting from the same place. So while those assets are importing into your project, I'm going to jump over to Unity, show you what it should look like. Okay, so here I am in Unity. Again, once you have this project open, you'll just want to go ahead and go to Scenes, open the starter scene. One thing you may note is that the lighting may be a little blown out. You may have some lighting issues. Don't worry about that right now. Again, we are going to discuss that in the next challenge. But you want to make sure that you're able to see some sort of materials here. So one of the things you can do to make sure that your scene is set up properly is to go to Window and drop down to the Render Pipeline, HD Render Pipeline Wizard. Okay. And you have this open. You'll be able to confirm that your project is configured. You can go ahead and then hit a Fix All here if there's an option. If any of these are not a green checkbox, you will have an option to fix them. So you can just click Fix All and it will go ahead and set that up. So that is a great first step. If your project is looking a little funny, or if you just wanted to ensure that you have the starter scene set up properly. The other thing that you may want to do, I'd recommend you do, is go ahead and go to the package manager and ensure that you are using the same high definition render pipeline version that I'm using here, which is 7.1.8. So go ahead and you can update if you need to. I think by default, some of them are set to 7.1.6, but go ahead and update 7.1.8. That'll make sure that we're looking at the exact same features. Updating the project to the latest HDRP version and then running the wizard. We'll make sure that we are starting from the same place. Again, if you're seeing some lighting that's blown out here, or you're seeing a bluish tint in the scene, don't worry about that yet. We are going to address that in the next challenge when we jump into the lighting. But for now, just wanted to make sure that we are starting from the same place. Again, if you have any questions, feel free to use the Q&A tab. With that said, I'm going to jump back to slides here. So we have the green thumbs up in the top right here. That means that it is go time for you. Go ahead and make sure that the starter scene is working properly, and you can use the HDRP wizard, and you can also update your HDRP package. Great, seeing a few notes that you may have seen some pink materials. So hopefully the wizard helps solve that. Okay, and if you are good to go and your scene is working with the materials and this starter scene is opening in your project and it's looking all right, aside from any bluish tint, or if there's some blown out lighting, we'll fix that. But if you're at that point, go ahead and just give me the thumbs up in the chat, or just give me a good to go, and we will continue on. Great. Looks like majority of folks here are in a good spot. That is awesome. As a reminder, I'm going to sound like a broken record, but really encourage you to use that Q&A tab. I see that a few questions are coming in. That's great. That's why we're here. That's why it's there. We want to make sure that we're able to address all of your questions throughout the session. So don't hold back. And with that, let's go ahead and continue on. Thanks for the responsiveness. This is great. All right, so today we are talking about HDRP. We are building on top of where we left off last time. So just as a quick reminder, HDRP is a high definition render pipeline, and it's really focused on the highest fidelity experiences in Unity. Okay. We've included the Heretic demo here. There's some breakdown videos that have been coming out recently. Really cool to check those out. And there's also a few Unite talks, ranging from introductory all the way to deeper dives in the high definition render pipeline. So if you're looking to learn more, there are some great resources out there for you. And why do we want to use the HDRP or the high definition render pipeline? It's the highest fidelity pipeline in Unity. So if we're trying to maximize fidelity, these really high quality experiences, the HDRP is going to be the tool we want to use. It is built on top of the scriptable render pipeline, which means that it is extensible. You can easily extend it for your needs. Okay? And as we'll see today, there are some additional lighting workflows and material workflows as well. So you can create some really great looking content using the HDRP. Included this slide here from the last session as well, because usually we get questions about the differences between HDRP, the universal render pipeline, and then the default renderer. So wanted to just drop this in here. Again, the session will be recorded, so you can come back and look at the slide or just grab a screenshot of it now. But today we're going to be focused on the HDRP, which is designated for the maximum fidelity experiences, and should really be used for higher end hardware, such as PCs and consoles. A little bit of a primer there, but now we're going to jump into our focus for today, which is going to be on the lighting and maximizing fidelity here. So we're going to start out with light baking. So I think it's important that we discuss what light baking is, in case you don't know or fully understand what it is. But we know that Unity is a real-time 3D engine. Right? So what does this mean? Well, this means that every single frame, right, the Unity engine is doing a lot of work. And you can see on the right here, there is an image from the Unity documentation that is some of the game loop. There's a few more steps in this as well, but generally speaking, every single frame Unity is doing all the physics calculations, handling all the input, running all the game logic, doing the rendering, and more. This is a lot of stuff to do every single frame. And when we're running these frames up to 100 times every single second, this needs to be efficient, right? So one of the things that we could do is we can leverage the fact that some of the lighting conditions in our scenes won't change every single frame, right? Furthermore, they may just be the same lighting conditions for the duration of the scene. Right? If we have environment lighting and there's not objects moving around on top of that, we can just calculate that lighting once, and then we can save it, and then we can load it in at runtime. Now this saves some performance at runtime, which just means that we can do more, right? We can take that extra performance and do more real-time lighting, do other calculations that make our scenes look really awesome. So the point I want to make here is that not only does baking the light save performance, right, or increase performance in our scene, but it also unlocks a few nifty features in Unity, such as light probes. Okay, and we'll talk about this in a challenge shortly. But the other thing we can do is we can bake extremely high quality lighting, right? Because we're not limited to running this every single frame, right? And if we're running every single frame and it's 90 frames per second, we're looking at, I think it's 16 milliseconds each frame. That's not that much time for Unity to do all of the lighting calculations. So if we do all the lighting calculations before runtime, we're not limited to that 16 milliseconds, right? We could let it bake for an hour, right, or 2 hours, and we can get this extremely high quality lighting and then load that in at runtime. It's important to note that baked lighting cannot be updated in real time, and while this may seem like a limitation, it's really just a consideration, right? We can focus on certain areas of our projects, and we can use some of the tricks like light probes, which we'll talk about here shortly, to make sure that our scenes are looking really great. Okay, and then this video here that just ran is the Lexus demo, and you can see some of this lighting, especially in the environment, is going to be baked on, and then you'll see the real-time lighting that's actually on the vehicle as well, right? So baked lighting is not mutually exclusive from real-time lighting, and the two can work together to create really high-fidelity scenes. So 3 steps to baking the light in Unity. Step 1 is you'll want to mark objects as static, right? So it's important that you only mark objects static if they are stationary, meaning they're not moving or they're not animated. They are staying in the same place throughout the duration of your scene. But if you mark objects as static, that is step 1. Then you can adjust your lights in your scene to be changed from real time to baked. And then the last step is to use the lighting window to bake that lighting. Okay, so just a 3-step process here, not too difficult, but we will walk through that in the first challenge. Note there is mixed lighting, which is a combination of real-time and baked, right? So we can do nifty tricks like baking the ambient lighting or baking the shadows and having some of the direct lighting continue to update. Right, and so that falls into the mixed category. Taking it a step further, there are some unique light baking features in HDRP. So I want to take a moment here to discuss those. If you've used the light baking in the default render, then you may have not seen these yet. But in HDRP, there is 2 additional areas that want to make sure that is cleared up for you. So on the volume, which is the settings for the scene, right? We can set the type of sky that we'll use. There's also an option to set the ambient mode, and this just determines how the ambient lighting in the scene is calculated. So there's an option to do it dynamically or to use a static ambient mode. So this is similar to what we did in the session 2 weeks ago. So if this is new, I would recommend checking that session out. But again, we can set these volumes up. We can have multiple volumes per scene. And this is essentially what the camera will see during runtime. Now, there is an additional setting that is new in the lighting window, and that is this environment setting, right? So there's an option to select a profile and then choose which sky is used to calculate the baked light in the scene. So what this allows you to do is you can bake the scene lighting using one profile or one type of sky, and then you could set it up so that you're actually viewing different skies through the camera in the scene. This allows further customizability of the scene, right? You can set the lighting the way you'd like it with one volume. You can bake that in, and then you are not limited to using that volume at runtime. So that's really great. You can have a specific volume for your baked light, and then you can have additional volume settings for runtime. So that was a bit of background on light baking, but now let's go ahead and jump in. Again, we do have the stop sign in the top right, so I'm going to recommend that you just watch as I do a quick demo, and then we will turn it over to you for the first challenge. So with that said, I'm going to go ahead and share my screen. Here we are back in Unity. Any console errors, this is good. So you should be in the starter scene here. The first thing that we're going to want to do is go to the global volume. And let me just prime this by saying we are going to be baking the light, setting up baked light in this scene right now. So we're going to do a couple things. We want to make sure that the global volume is set up so we don't get this kind of blown out look over here. We will set the objects to static, change the lights, and then bake the lights. So let's go ahead and do that now. So with the global volume set, some of this blown out light can just be from the HDRP not knowing exactly which sky you're using. So what you can do is with the global volume selected, hit type, and then we can add a sky in. I recommend that you explore this and add some skies in. Again, you can reference that session 2 weeks ago if you're unfamiliar with this, but for now, I'm just going to turn it on none because we are in this tunnel scene, right? And we don't need to worry too much about the sky. We are just focused on this interior lighting here. So I'm going to set this type to none. That's going to be my first step. And now I would like to take some of the lights that are in the scene and I would like to bake them in, right? So we can see how that works. What is the first step to any light baking? If you'll remember from that previous slide, the first thing we always need to do is determine which objects we would like to include in our baked lighting. Right? In order to determine which objects, we just have to set them to static. So this scene is set up nicely because there are 3 kind of parent objects here that have all of the stationary pieces. So I'm just going to select tunnel pieces, exterior, interior props, go ahead and click this static button up here. It'll ask me if I want to change the static flag to the children, and yes, I do. So it'll change all the way down. Feel free to open these up and see exactly what's in there, but these are essentially the stationary items in the scene. So that is step 1, right? We set the scene to be static. That's going to let Unity know that we can go ahead and we can bake this lighting in to these objects because they are not going to be moving at runtime. Step 2 is setting up the lights to make sure that they are able to be baked. So how do we do that? Well, we need to identify where the lights are in the scene. We could go through and do this manually. We could select the directional light, come in, change the mode from real time to baked, and move down the list. However, in a scene like this, especially one that you didn't build yourself, maybe you're revisiting, haven't seen it in a while, there is a nifty tool to help us with this. So if you go to Window, go to Rendering, and open up the Light Explorer. This is a really handy tool. I'm just going to go ahead and dock it down here because we'll be returning to it. The Light Explorer shows you all the lights in the scene, right, in one kind of nifty window. The thing that's really cool about this is we can enable and disable, we can modify these lights right here, so we don't need to be searching through a hierarchy to find objects. Again, we want to convert some of these lights from real-time to baked, and then we want to bake the light. I'm going to be focused on this kind of main area here for the duration of the session. So what I'm going to go ahead and do is I'm just going to disable some of the extra lights, and this will just make sure that our light baking happens faster while we are demoing this here. So these ceiling point lights, they are not going to be in view right now, so I can just select them. I can turn them off. I'm really just going to turn off most of the lights that we're actually not going to be able to see right here. They're just scattered throughout the scene. Again, as you build out the entire scene, you'll want to turn them back on and include them in the calculations. But again, for now, I just want to focus on a few so we can really see exactly what's happening. So the few that I want to focus on, the directional light, which we can see coming in over here, and then the spotlights, which are the lights in this room. So if we turn these off, you can see where they are, right? So these 3 spotlights light up this kind of main area. So again, we could go and we could click this and it will show you where it is located in the actual scene, or it should, right there. And I could go into the inspector and update it here. But what I'm going to do is I'm going to use the Light Explorer to update from real time to baked. So I'm going to select the spotlights and change these to baked. I'm going to do the same thing with the directional light. Go ahead and do baked. You'll notice that nothing has changed in the scene yet. That is because Unity is going to keep that real-time lighting until we configure it in the lighting window. Okay. So that was step 2. Right? We converted the lights to be baked. And then the last step here is we're going to go into the lighting settings. Okay. And I'm going to dock this window as well. So we'll be returning to it over here. Great. In the lighting settings, by default, baked global illumination will not be enabled. So we'll want to turn that on. But first, we want to make sure that we have a profile set here. Just a best practice. We're not using a skybox to bake into our scene, but it is just best practice to have that profile set. So go ahead and set that. This profile that is used in the scene is called the Spotlight Tunnel Main. You can set that there. The next step is to set up baked global illumination, so we can just enable that easily enough. There are a few lighting modes for the mixed lighting, so you can check these out here in a second, but we'll just leave it at baked indirect for now. And then we have the light mapping settings. So a light map is, as it sounds, it's a map of all the lighting in the scene. So when we do a light bake, all that lighting data gets saved into a map, and that map is where Unity loads that information from at runtime. So the light mapping is the process of baking the light, right? And the light map itself is the area where that data is stored. Right away, you'll have these default settings. You can choose whatever light mapper you want. If you're on a machine that has a powerful GPU, it's going to be faster to use the GPU-based. If you have a more powerful CPU, go ahead and use the CPU one. And then one nice trick here is we have all these samples and we have this resolution. And these are just going to be the quality of the lighting. So what I like to do when I'm working is actually bring these down to their minimum values to start. And this just allows me to generate the lighting quickly and iterate quickly. And then once I have it in a place that I like it, then I can go ahead and boost these values up and get that really high quality lighting. The light map resolution is going to be the resolution at which the lighting data is saved. Something that's cool in the scene view is you can actually pop down this shaded selector here, and you can look at I believe it's the baked light map, and you can actually see how this resolution would affect the lighting in the scene, right? So as you increase this resolution, you're going to get higher and higher quality lighting at the cost of more time spent in that light baking process. So that's a little cool aside there. I'm going to go back to the shaded view. And again, I'm going to bring these values down. I don't need to calculate too much bounce lighting. Again, I can come back in later and boost these values back up. But I like to just bring these down while I am developing. So we have that all set up. We can go ahead, and I believe at this point, if we generate the lighting, we are going to see some results. So now that we're generating, it has changed our lights from real time to baked, as we have told it to. It's going to go ahead and generate this, bake this lighting. So this will load in just a second, and I will show you the results. But let's not wait for that. Let's go ahead and jump into the challenge so that you can dive in and we can make sure to get all of your questions answered. I see that we've already had loads of questions, so appreciate you for dropping those in. Let's go ahead and jump into the challenge while this finishes its baking and setup. And then continue to ask those questions. We'll spend a few minutes on this challenge. So let's take a few minutes now and just go ahead and bake the lighting in the scene. So this should be the steps that you need to follow to do that. And then feel free to let me know in the chat when you have that set up. And as you have questions, feel free to post them in the Q&A and we will address them there. If you have got that set up already, that is great. Encourage you to explore some of the additional light map settings and modify some of the lights in the scene and see how great you can make it look with just the light baking. With light baking alone, you can actually get some really, really great results. So, just this step can really enhance your experiences. Again, because you're allowing Unity to do all of this pre-work, and then it's not bound to that the frame rate, right? To doing it every single frame. So this is generally um, a good call to implement all of your projects because one, you're making it look better, which is why we're here, but you're also increasing performance, right? Which is always good. It means we can add more features, or at the very least, we can save battery usage. One thing I want to call out with this last pro tip here, as I mentioned, we can reduce the number of direct samples, indirect samples to quickly test. The thing that you'll want to remember, though, is before you go into production, that you boost those values back up, right? Once you have everything set in your scene, you want to bring those values back up, then you'll just get the highest quality lighting that you can have in the scene, which is great. So let's go ahead and continue on to the next demo here. So what we want to do now is we would like to configure light probes. Light probes are a really awesome tool that essentially allow us to take all of that baked lighting goodness that we just set up and then apply that to objects that are not marked static, right? So we have this train in the scene, for example, and we know that it's real time, right? Ideally, that train is moving along the track, whether it's animated or controlled by the player, but we need to have real-time lighting on that train. Now, that's a bummer because we have all this great baked lighting. How could we apply that baked lighting to the real-time object, right? I just said that that's not possible. Well, the trick is we can use light probes, right? So light probes will take that baked lighting information and apply it to real-time objects. So it's kind of the best of both worlds in a lot of ways. Rather than just continue to talk about it, we'll just go ahead and jump into the scene and show you what that looks like and how we set that up. So here we are in the scene. What we'd like to do right away here, just go back to the inspector and just look at something in the scene. Like to set up light probes in our scene, right? So again, light probes are going to be a way to enhance your scene's lighting, right? So taking some of that baked lighting goodness and applying it to real-time objects. So how do we set them up? Well, they are a game object, so we can just create them. So you go to light here down to light probe group, you'll be able to create one. But what I want to focus on here is these tunnel pieces. So in the tunnel pieces, you can see this large tunnel section, and I'm just going to zoom out a little bit so you can see what that looks like. We have this large tunnel section, and the nice thing about this is that each of these tunnel pieces is a prefab, right? So what we're going to do is we're going to set up the light probes on one prefab, and then it will propagate across all the prefabs. So that's just a nice shortcut rather than setting up the light probes manually throughout the entire scene. Again, we're going to focus on this main area, so I'll choose this large tunnel piece. What I'm going to do is I'm going to click this little arrow to open it up in the prefab view, okay, and this will just take a second to load properly. I'll start to look a little bit better here in just a second. But while that is loading up, what I would like to do is go ahead and create a light probe group. Okay, so the light probe group is, as it sounds, a group of light probes. Now what we can do with this is we can click edit here, and we can start to move these around to fill our entire space. So I'm going to go ahead and click edit light probes. Okay, and what you can do in the scene now, in the scene here, is I can start to select these and manipulate them. So there's kind of some tricks here that you'll pick up. So what we can do, just go out of edit mode here for a second. I'm going to move the whole light probe group over so that it is positioned in the prefab properly. So what we want to do is we want to make these light probes encompass the entire scene. So the way to do that, click Edit. You can select these or select them manually. And then just like game objects, you can duplicate them with Command D or Control D. We can move them around. You can see as we add more, you can see the lines connecting, showing you where each of the light probe sections is. Okay, so what I like to do is I like to move across one way. So in this case, moving across the X. Then I like to move across another axis. And then by the time you get across the third axis, they are set up in your scene. So what we can do here is we can just zoom out a little bit. I'm going to go ahead and select these top ones, duplicate, slide them across. Okay, we can make sure that they are moved close to the edge. We don't want to go through because we don't want to sample light from outside of the walls. It doesn't make sense. We want to sample light from inside. I can select these, move these across. What I can do now is I can select the top row. I can duplicate these, and I'm going to go up. Okay, and then I think you start to get the idea here. We can configure this so that it fits nicely in our tunnel. Okay, so we'll just do one last one here. We'll just duplicate these. And then, we've filled out the entire scene. One more. Gotta get these guys right here. So what is the best practice for spacing of these? Typically, you can follow the default spacing. So when we first started it, you saw that cube. That is a good default spacing, about 1 meter to 2 meters apart for each of them. But you want to move them throughout the entire scene. What these light probes are going to do is they're going to take all that baked lighting information and they're going to store it. And then when real-time objects come through the scene, they're going to apply that baked lighting to the real-time objects. Now, it's going to be somewhat of an approximation, right? It's not going to be as good as real-time lighting, but it's definitely good enough for a lot of the use cases. Recently, on the work that I do, I was working on a project for a large biotech company, and it was deployed to the Oculus Quest. The real-time lighting on the Oculus Quest can be a challenge, and so we ended up lighting the entire room and the entire device that we were training on with light probes, right? So we didn't even need to use real-time lighting at all. We just baked all the lighting and then used light probes, and the light probes applied that baked lighting to the object. Once we have the light probe group set up, we can go ahead and then just save this asset. So I just click back here, that should save. And then not only will we have the light probes in that one tunnel piece, but we will have it in all of the prefabs that match. What this does is allows us to, again, have a real-time object that when it moves through there, it's going to take that light probe data and it's going to be applied to that real-time object. I just went ahead and set that up, but now I want to turn it over to you so that you can set it up, and then, again, we can help address any questions that are coming up. So with that said, we'll go ahead and share back into the slides here. Let's go ahead. Green thumbs up means that it is your turn to go. So go ahead and create a light probe group. Again, using the prefabs is nice because then it's going to propagate across all the prefabs. But you're not obligated to use prefab workflow. You could just create the light probe groups separately and manually move them through the entire place. But the pro tip here is to use that across prefabs to save you some effort. So go ahead and give this a shot. Let me know in the chat when you have that set up. And in the meantime, we will continue to address some of these questions. Great. So I'm just going to jump in and help answer some of these questions while you guys are working. We have a question here about the light probe proxy volume, and what does that mean? So the light probe proxy volume, let me take a step back and say that once you have the light probe groups set up, if you have a real-time object, right, and it moves through, it's going to take information from those light probes. That works really well for objects that are smaller than our light probe group, right? They're smaller than each of those little boxes that we set up. If we have a large object, such as the train in this example, what can happen is you'll have one set of light probes be apply its light to the entire train. And that can look kind of funny, right? Because the train maybe extends across multiple groups. So what the proxy volume allows you to do, it allows you to say, okay, this object is going to require information from multiple light probe groups. So you can just add the proxy volume to any large object that you would like to pick up light probe information, and then it will apply more accurate lighting across that entire object. Seeing a note about it's still bluish after baking the lights. Yeah, so make sure in your visual environment, which is on your global volume, that you set the sky to none. And that's just going to make sure that there is no sky influencing that baked light. If you are unable to select individual probes, what you can do is you want to make sure that on the light probe in the inspector that you've selected edit probes, and that'll allow you to actually select individual probes, or you can do the drag select like I was doing. But you have to turn on the edit light probes button in the light probes inspector. Which is better, one big light probe group or many little ones? Doesn't really matter. What matters is the density of the individual light probes. Right? So you can have multiple game objects or multiple light probe components set up. That's fine. It's the same as having one. But what really matters is the density of those light probes. We have a few minutes left. I want to make sure that we get to the last couple challenges here. So let's go ahead and jump back in. Thanks again for keeping me up to date in the chat. It's great to have a responsive group. Also great to have the questions coming in. Again, the session is to get your questions answered. So really encourage you to take advantage of that like you guys have been. So let's go ahead and continue on to the third challenge here. The last one will be a quick one, so we should be able to finish here on time. What we want to do now is we talk about light probes, right, and how they can help apply our baked lighting to our real-time objects. The other type of probe that can really enhance the scene is a reflection probe. Okay, so I'm going to jump into Unity here and show you what that looks like. So share into Unity. You should see my Unity editor now. And then what I'm going to do is I'm going to collapse hierarchy a little bit so I've got some space to work with. And what I'd like to do here is now create a reflection probe. Okay? So reflection probe is a tool in Unity that enhances reflections and reflective materials in the scene. So how do we add a reflection probe? Well, if you go up to the top left here, we can just go down to light, and then there's an option to select reflection probe. Okay, right away you will see that you get this nice big box, and this can be a little confusing. What does this box exactly do? Well, I'm going to go ahead and just center it in the tunnel area here, and then I'm going to explain what this does. So when I created this reflection probe, you can see not only do we get this box, but we also have this kind of sphere looking thing, and that is the actual probe itself. And it's not visible in the game view, right? It's just visible in the scene view as a helpful guide. But what this reflection probe is it's a camera, right? So this little center thing here is a camera that is picking up all the information around it, right? So it's picking up these walls, the train tracks, right? All this lighting information as well as just the materials, picking up all this information just like the Unity camera does. Right? What that allows you to do is you can take that information and then you can apply it to objects that need to reflect, right? So if you think about a mirror, simple example, that mirror needs to reflect whatever light is bouncing off of it. That's not going to happen in Unity by default. The way you make that happen is you create this reflection probe. That reflection probe is the item that picks up all that information and then applies it to that mirror material so that it can start to reflect accurately. Now you may say, okay, well, we don't have any mirrored materials here, so why would we include a reflection probe? Well, the important thing about reflection probes is that even if it's not a completely smooth, metallic, mirror-like material, there's still going to be some reflective properties. So by including a reflection probe, even if there's not something that's like mirror-like in your scene, it is going to improve the look of the lighting. Okay, so we have this reflection probe set up. There are a few settings here. The important thing to do is set one of these up kind of per area, right? So you want to set one up per area in your scene, and then you want to make sure that this center ball, this capture piece, is located relatively at the center of the scene, right? This is going to be where that camera is picking up all the information, and then it will apply that lighting data to the objects in the scene. So pretty simple here. We just set it up. The green boxes here determine which objects can access the reflection probe's data, right? So if we kind of zoom over this way, we can see that something like this railing is inside this box, right? So if it needs to reflect something, if this material is slightly metallic and wants to reflect, it's going to look to this reflection probe to get that data. Reflection probes can be baked or real-time, or you can hook them up to run manually through a script. We can just switch this to real-time. And what you can see, it's actually really cool, is you can actually see, as I was describing, the information that this reflection probe is picking up, right? So this is the reflective information that then gets applied to the nearby objects. So that will be the next challenge, is setting up a reflection probe. Relatively straightforward, but again, a really easy way to increase the fidelity of your scene. We are coming to the end of the session, so I'm going to jump into the final demo here, which is something else cool, and then we'll have a minute or two for you guys to jump into the challenge. The last demo here is with the Decal Projector. And so let me just show you that. So the Decal Projector is a really cool tool that is unique to HDRP. And what you can do is you can come in here, right, bring this down. What this little thing is that I just created, the Decal Projector, is it projects a material onto surfaces. So this is really cool when you want to create something like a spray paint effect, or if you are creating a shooter game, this can be great for bullet holes or splatters. You know, or in this scene, you could find, you know, some spill texture, like a water spill or an oil spill, and then you project it on top of the material. So it's a really simple way to kind of project on top of existing materials. So what we're going to do is go ahead and set this up here. This is a little box that is projecting. The green side of the box is where it's projecting to. So I'm just going to move this onto the wall here. It needs a material, so we can just create a material quickly. Create a material, we'll call it decal. There is a special shader for it. So in HDRP, there is a decal shader. And then I've included a Unity logo in the project. So you can select that. We'll just project the Unity logo onto the wall here. Drag that material in. Okay. You can see it is backwards, but we can flip this around, and then it will look pretty good. All right. So you can mess with the scale of this thing to make it actually start to look kind of nice. And again, the cool thing about this is that it doesn't care what it's projected onto, right? It's just going to be mapped right over the top. So that is a really cool effect. All right, so we are coming to the end of the session here. I'm going to jump back into the slides, and I'll stick around for a second to make sure that your questions are answered. But I do want to make sure that we hit the few closing notes here. So come back to this. We set up the Decal Projector, a few steps there. But we've covered a lot in this session, so you can take these and apply it to really any HDRP project, and you're going to enhance the way it looks. Go ahead and join us in the Connect group. We have an updated bit.ly link here we will drop in the chat. If you build this project out or continue working in it, we really encourage you to drop it in the submission link here. That allows us to look at it, and we can all join and provide feedback there, and it's cool to see what you guys are able to do. With that, we are at the end of the session, so join us in the Connect group. That's where we can continue the conversation. And if you'd like to connect, you can find me there at bit.ly/AndyXR. And again, I'll stick around and help answer a few questions. But thank you for joining, and we hope to see you in a future Learn Life.